All right, Bismillahirrahmanirrahim. Students, very important numerical we are doing. Just to let you know that we have done this numerical on the mechanical design of solid software. Determine the force in each member of the truss as shown, and also calculate whether members are in tension or compression. Okay, so this was one of our numericals that we have done on MDS. If you look at it over here, remember, so if we go here and if you look at it, sorry, if you look at it is 122.5. we call this as equation number 1. Okay, now if we go to the videos, so this was the video that we have done. We have done it on MDS, okay, on this numerical. So you have to, we will try to do it on analytically by using the method of joints. Okay, so we will try to do this analytically by using the what method are we going to use? We are going to use the methods of joints. So this is the truss. It's 2 meters in height and 2 meters along the length, and this is the resultant, making an angle of 45 degrees. So start in method of joints, we have to select a joint on which there are basically not more than 2 unknowns. Okay, we could not select a joint AC because there are 4 unknowns at A and 3 at C. So we have to select a very unique joint where there are not more than 2 unknowns. Okay, so if you look at it here, you will have basically a pin over here and an unknown over here and unknown over here. So we cannot select this joint A, we cannot select joint this because there will be one unknown here on CB, BC, and one unknown here, which is basically AC. And since the ruler will give you one direction, so one unknown here. So 3 unknowns here, and we have 4 unknowns here. So remember this thing, we have at this point we have 3 unknowns, and at this point we have 4 unknowns. And if you look at it here, you will have 2 unknowns. What are those? Force BC and force BA. So very important point, we could not select joint A because there are 4 unknowns at A and 3 unknowns at C. So we select joint B as there are 2 unknowns. Okay, so this is a very important assumption for using the method of joints. Okay, so once we select joint B, if you look at it, there is this force 500 Newton force, then there is basically this force BC, and then there is this force BA, okay. So we assume that force BA is basically as tensile, and we assume this force BC as compressive. Okay, it is our choice. You can assume the other way around. Okay, if your assumption is right, your answer will be positive, and if your assumption is wrong, your answer will be negative. So at sigma fx equal to 0, this is joint B, and this is the picture of the joint. 500 Newton, we assume sigma fx equals to 0, 500 Newton, and then we have this force BC, which is basically making an angle of 45 degrees. So basically if you look at it, it will have 2 components. Okay, one component will be force BC sine 45. Okay, and again if you look at it, this will be, there will be 2 components for this. Okay, one of the components will be in this direction, and the other one will be basically towards the positive y-axis. So basically you will have one component in this direction and one component of force BC in this direction along the x, and see this component is towards the this, and you remember very important thing, this is our x and this is our positive y. This is x, positive x, and this is our positive y. Always remember this before, always use this symbol to help you. So this component is going to be minus force BC sine 45. Since 500 Newton is towards the positive x, it's 500. So from here you get force BC as 707.1 Newton. Okay, so for force BC we have assumed that it is in compression. We have assumed, so our assumption is right. So it comes out to be a positive value. So if you look at it, what about you apply sigma Fy at joint B. So when we apply sigma Fy, we get force BC cos 45. Again with this, it is this component which is acting towards the this component. This is our force BC sin 45. If you look at sigma Fy is basically, if you look at it, this is force BC, sigma Fx we say along this component as force BC sin 45, and again this was the negative x, and this component will be force BC cos 45. Okay, this component will be force BC cos 45. Okay, so as this was our force, this was our force, remember. So it will have two components, one this component and the other one will be this one. It is force BC cos 45 minus FBA. So you get FBA equals to 500 Newton. Again our assumption is correct, because this was our assumption for force BA as tensile, and the answer which is coming is also tensile. Okay, so now we go to joint C. Okay, as joint C we go, because you look, we have already calculated force BC. Okay, so force BC is 7 and 7.1 Newton along this joint. So if you look at this is calculated, now we can calculate force AC and basically the roller force, which is the vertical force towards the positive y-axis. Okay, force AC, and you can see, you can look where there are again two unknowns, force AC and CY. So when we apply this, if you look at it at joint C, so at joint C basically force BC is basically already calculated. So again we have two unknowns. So this is our joint C, this is calculated, this is unknown, force CA and CY. Okay, so very important point, since we have assumed force BC as compressive at joint B. Okay, so we will assume the same assumption at joint C, as force BC will be again compressive at joint C. Okay, and if you add the two forces, they will cancel out, as the force BC bar truss member is basically in equilibrium. So sense of force BC is compressive at point C as it was at B. Okay, you cannot assume it as tensile, it will be wrong. Okay, sense of force CA and CY could be assumed. Okay, we can assume that force CA is tensile or compressive. We assumed it as tensile. Okay, and again roller, as you know, basically is always going to be in the vertical direction and trying to basically act as a in this direction towards the positive y-axis. Okay, so we can resolve it in its respective components basically. So again, if you look at it, this is again joint C, sigma Fx equals to 0. If you look at it and if you want, we can basically so at joint C, if you look at it, it will be minus force CA plus 707.1 cos 45 equal to 0. Okay, you can see over here, if you look at it, this was our respective components. Okay, this minus force CA, okay, this was this force, and this was the component of BC. So we assume one of its components along the x-axis. So minus force CA plus 707.1 cos 45 equal to 0. So you get force CA equals to 500 Newton tensile. Now we apply the vertical force. Okay, sigma Fy equal to 0. If we apply the vertical force sigma Fy equal to 0, if you look at it, it will be one component as this on CY because of the roller, and the other one will be because of the force BC. It will be the sin 45 component, but it will be basically acting in the negative y, and CY will be acting in the positive y. So you can see CY in the positive y and 707.1 sin 45 minus. So CY comes out to be 500 Newton. Okay, so we have resolved the unknown forces at joint C. Okay, and then basically we go to joint A. Okay, if you look at it, this is our joint A. We already have calculated the force AC. Force CA has already been calculated. Okay, you can see we have already calculated as 500 Newton, and since it was tensile, so when we go at joint A, we also assumed it as tensile. Okay, because this truss component has to be in equilibrium. You add, when we are doing joint C, force CA, and you again add the force when doing joint A analysis, you add them, basically they will have to be in equilibrium. So at joint A, this is our tensile force. Okay, and then we have calculated the force BA, okay, which was also assumed as tensile at joint B. So at joint A, we also assumed this force as tensile because the truss component has to be in equilibrium. So what we will do, and then these two components AX and Y, they have come here because the pin will have two reactions, AX and AY, and the direction again we have assumed as in this direction. We have assumed this is the direction of AX and this is the direction of AY. You can assume it in the negative way X. You can do AX in this direction towards the positive X and AY towards the positive Y. You can assume the other way around. We have assumed it. Okay. So now if we apply sigma Fx equal to 0, we get 500 Newton. This was the force CA minus AX towards the negative X. So AX is 500 Newton. Sigma Fy, when we apply, we get 500 Newton positive and minus AY. So you get AY equals to 500 Newton. So we have resolved all the unknown forces at the respective joints. Okay, at BC, BA and AC. Okay, and we have found out that force CA, if you look at it, we have found it that force we have found that force CA is in tension, force BC is in compression, and force BA is also in tension. Okay, so if you look at this one, this is telling you respective force members. This was our BC, compression, force CA was in tension, and force BA was also in tension. Okay, so this is how we basically compute analytically. We can analytically solve a truss by using the method of joints. Okay, so and we have also, remember, done the same problem on the software, and we could, the results could be compared basically on analytical results, and the simulation results could also be compared to find the percentage difference in the calculations analytically and computationally. Thank you very much. I hope you have understood this problem really well. Thank you very much.